Correct? If it did the right child, it will look something like this.
Left becomes
You're telling
right.
that you need to swap it, right? Where do I swap it?
No, you just
It's in
swap the
middle, right?
pointers.
You just swap the pointers, right?
You don't
Oh.
have to swap anything. No, I took the question different way. I thought
Oh, you're not comparing?
two trees.
No, no, no.
Yeah, so that was my
That
other
would be separate.
Oh.
Right? That is also good too. Okay.
Yeah,
Then do recursive or iterative?
recursive.
Okay.
I can do it.
Okay.
Dot right is equal to
swap करने के लिए दो change करने थे. Fast करना पड़ता है.
Root left is the root right.
See, चलेगा. I'm just saying this. This line, you should have taken it here. Swap.
so over here I
So we
think
will have to first do this,
Ah.
and then this swapping, and then second swap, right? So
Ah.
we'll have to do in order traversal for this.
why?
Why in order?
Why? I think this is it. This is it.
See, but why would this work?
You're swapping the children's pointers and then you're passing the child's.
Yeah, that will also work.
That's it. That will work. And you're like the interesting thing is that the last two lines
Mm-hmm.
doesn't matter. You can write left or right.
Yeah, you can do any traversal actually in this case. You can even go reverse in order, reverse pre-order, whatever you want.
What is reversible order?
So your in order is left, center, right.
Yeah.
It will be right, center, left. No, I copied.
So reverse pre-order is post order.
Reverse, post order.
Reverse pre-order is post order.
Reverse, reverse post order is
Pre-order.
Your in order,
Let's print
in
it.
order, pre-order, post order.
Hmm.
Never your right child will come before your left child. If you are reversing, then
Right
your right
child
child
will come.
will never come before left child. In
Okay.
these three.
Okay.
When you reverse any of these,
Yeah, yeah.
your right child will come before your left child.
Okay. Okay. Yeah.
Okay. So let's say
So inside this if we are when it is root is null, we are coming out, right?
Yep.
So if any one of the node is not there, I am coming out. How can I go to left side or right side?
So there will be a condition.
No, but if you are, okay,
It's
in this case,
okay.
if you are at 2,
Huh?
you will say, am I null? No. So you will take a temporary variable for 4,
Hmm.
okay? You will swap it with right.
Hmm.
So
So
now,
your this becomes null. This is the new one, okay? Blue is null, new,
yeah,
okay?
and right will
This will become right, correct? Then you are saying swap root left.
null.
So you are swapping left.
Okay.
When you call this guy, he'll say, oh, I can't do anything over here. I just return. So this will be taken care of. And then you'll say swap root right.
Mhm.
Correct? You come here. Your null will get replaced by null. Both nulls will get swapped.
So we can put one condition on top of node temp that if both root dot
Both-
left and root dot right both
Yeah.
are null, then do nothing.
Do nothing, or you can, one iteration will not kill you.
Right.
So,
Just
sure, I'll just drop this.
It was 3, 4, right?
Huh?
3, 4.
Doesn't matter.
Yeah.
Ah, 5.
Right. Yeah.
Okay. Let's say you are given a tree and you have to find if there exists a path that starts anywhere and ends anywhere, and the sum comes out to be the given number. So at this point in time, it's starting here. This is your
So let's suppose it's 10. So 1, 3, 6 is that correct?
1, 3, 6, yes.
So in that case, it will return true. That, okay.
No, you have to actually return all the paths.
Oh, you want all of that.
This is the question.
Okay. Oh.
Yes.
I think I solved for.
You have solved has paths. Huh?
has got some, but all
Has
the
some
parts.
paths.
Yeah.
4 plus 5 is 9, but there is no path.
There is no path, so you have to find a path. So
Okay.
1 plus 2 is 3, 3 plus 5, 8, now 3 plus 6, 9. I was actually looking if there is somewhere I can actually have one more path.
Just put 10.
Yeah.
1, 3, 6 and 3, 7.
Yes, okay, let's do that. Good idea. Okay. 6 plus 3, 9 plus 1, 10, and 3 plus 7, 10. So you have to print out 1, 3, 6, and 3, 7. How will you do it? This is given in the Career Club book. It has one step which doesn't really make me happy, but okay, it is what it is.
Oh, yeah, no.
Hmm?
So we can actually keep doing the in order reorder reversal
Mm-hmm.
while we are moving. We
remember this can start anywhere.
Yes, we keep summing.
Mm-hmm.
While we are summing, we are actually calculating this number. If it exceeds 10, then the earlier number we remove that. Like for example, in
Okay,
step 1,
so-
there was a, for example,
1, 3 and 7.
yeah, 137.
At 7 you will realize, oh, I have increased, so you'll remove 1.
Yeah.
Okay.
The first one we keep on removing until we match the number. If it is not matching, we put them back. Huh?
And this is a binary search tree.
No. Is it a binary search tree? No, it's a binary tree.
Oh, it's a binary tree. So those traversals.
Isn't it obvious it's a binary tree? Your root is the least.
Yeah, but
Actually,
actually
we
is staying the same, right?
Yeah, your logic will work in here also.
Your logic will still work, but you will have to, at every point in time, you will have to create an array.
Yeah, and keep pushing the point.
Yes.
How do you plot it? If it-
How will you do it?
Discard it. So you just keep going till 1 each of the
wherever she's storing it, she's closed.
अगर 10 से ज्यादा जाना होगा तो उसको ऊपर वाले को remove कर देना.
The problem is we have to tell all the paths.
Yes.
We need to also
Or get the
maintain
study
the
cover now.
paths.
Yeah.
तब तक कर.
Okay.
Very
So
good.
if you were to be at this point in time, where you have 1, 3 and 7, if you start from here, will it help instead of starting from here?
So first you will have to solve it for very first problem, which are like printing 1, 3, 1 to 4, 1
No,
to
you can
5.
start from here, and in a data structure you start traversing, yes, you can go a DFS, and then when you reach the leaf, or at every level, you say, have I reached the sum? If I have reached the sum, print it, and then still continue. Because you never know, these could be negative.
Oh, these could be negative, then we'll time the full program.
This will not help. What if like 3 and 7 are before?
3 and 7 are?
So we are taking this scenario, this particular scenario where we have 3, 7 and something else.
3, 7 and something else, right? That's what I'm trying to say.
So if
That-
you come from the back side,
9, 11, 12, whatever. At some point in time, you will have only 1, then you will have only 3, so you will say, oh, 4, no. Then you come here and say 7 and 3, oh, I have 10, this is a path. Then I will come 1, 3, 7, minus 1. Oh, this is a path. Then I'll come 1, 3, 7, minus 1, 5. This is not, there is no path. Correct? And this is just assume that there are no problems here. This is solved in her book. I'll solve it. She has solved it.
so it's a post order.
Yes. It's how is it post order? Post is where your root comes to the end. Over here, your root is actually coming in the first. You are doing a pre-order traversal, but you are actually looking at it from the reverse. So, if you want to call it, you can call it a reverse pre-order traversal, but don't try to fix a pre-order in order in every case. In this case, what she is doing is she is traversing from starting from here. She'll go left and right, start putting it in an array list, so you don't have to worry about size. And then from the end of the array list till the time you encounter a sum, you'll keep going.
Okay.
and then you'll print it out. We'll print the solution. Come in, you say no head, just return. Take a temporary variable. In your array list, you are adding the current node's data. And then you are seeing in your buffer, have you ever encountered the sum with this new data that you have? If you have, you are printing it. So this print function will essentially just traverse from index to level and print it out. I fail to understand why she does this, but she creates a clone and then she's doing the same thing for the left and the right side. So if you look at it, this is an in-order traversal.
The reason for clone is
The reason for clone is she doesn't want to
update the existing array list, right? She wants to
no, actually, I think what she's doing it is actually she can do a buffer.delete at the end because you don't need buffer at that point in time over here. There it is.
we met the zero. Yeah, met the zero. Then
Why?
Why do you want to?
There could be
Negative number.
There could be negative numbers, right? So you can go -1 and then you encounter +1. So again you come here. So this was 137. So you come here. Wait. Sorry. Something like this. 3, 7, 10. You printed it out. But that doesn't mean this doesn't
right.
make it here. It's a good solution.
In the recursion, we are
Pardon me?
so we are calling find sum for the next level, right?
Yes.
In the next level, we are creating another buffer,
Yeah.
and that buffer is
That buffer is
These
whatever
buffers
path we
plus
have
new buffer.
traversed, and then whatever you will traverse in the future.
okay.
Excuse me.
So that means if there are 20 nodes,
You will create.
there are 20 buffers that we are creating, right?
Yeah.
I think that's not correct actually. Instead, like whenever we are coming back, we just remove that node.
Yeah, that will become like stack.
Huh?
That will become like stack.
That will
Whatever
become
you
like
added
stack.
at the end, you are removing.
So whenever you are coming back, you are
You are going to remove only the last one,
Yeah,
right?
yeah. So at
Over
least in
here,
that we will avoid actually having so many.
So many clones. Yeah, this
Yeah.
I don't know what will be a
The-
good solution.
I think,
Recursion.
I think even that is better having one
What I understood
buffer
is-
than so many buffers.
no. What I understood is you are trying to assume that you are starting from node 1.
Yeah.
But so every possible node is a start point. And because of that, you need to have those
Yes.
buffers.
No, as like we went to the very last one,
You have one, then you have 2 and 3, right? So from 1, you have 1, 3 and something. When you eliminate 1, you have 2,
you have one,
3.
2, 3.
Okay, let's discuss this later. I want to solve two problems. You done? Okay. So you are given an array in ascending order. I want you to create a tree out of this, a balanced binary search tree.
Start with the center
Okay.
and then,
Then?
move left, 2 pointers left and right and just
2 pointers left and right. So 6, then 1 to 10. Okay. And then
How come
So
to
6 and
8, 7 and 9, right?
7 and
okay 7 and 9. Then
now we will
6
less than.
and 10.
this will not be balanced then?
Five.
Again, no, sorry. Again from the mid, you again do it, again do it half.
Okay.
And then
Make it
make
mix-up.
left and right, yeah.
Okay.
4 and here.
And then go half of.
And again half.
So seeing something here.
Binary search.
Binary search.
Yeah, you're creating a binary search tree, but
Yeah.
about the algorithm.
It's a binary search. So you go.
It's
Interact-
recursion, right?
Recursion,
Yeah.
yeah.
So how will you do it?
By left
Simple.
is less
Yeah.
than right half.
So
So take an array and then
Why?
take index.
your end is less than start, okay? Your end is greater than start.
Take the mid.
Actually, let's make this a breakpoint. If end is greater than start, return it. Okay?
N is greater than star.
You will start with this is start, and this is end. Correct?
Okay. That's your. Why do you return it?
So end with
So
all.
if your end is swapped,
Oh.
you have already taken care of it. Now you will have int middle. What will be middle?
Start plus 7 by 2.
Are you sure? Start plus end by 2. What if your int is int max? What will happen to this?
That should be long then.
No, that's.
No, no.
You are overflowing.
Yeah.
How will you how will you fix this problem?
Oh, exception. You can use overflow.
You can't throw an exception.
You can
Okay.
subtract. And
Okay.
start by 2 is the same thing.
End minus start. Are you sure? This is start by 2 plus end by 2. Are you saying is it the same as this?
No.
Okay.
If it's.
So what is this? Start by 2 plus end by 2? This is end by 2 minus start by 2. Will this fix it?
So start by 2 plus end by 2, that should also fit, right? No, not.
Start by 2 plus end by 2.
That can also fix it because end by 2 is gonna make it half and then you are ready.
Yeah.
And
that
also
also.
fixed.
Yep. So this is usually how they do it. In that, which is the other book?
The Aziz.
Adnan Aziz.
Start.
Anyways,
And you want to make that lower, less than, not the greater than. And
if end is, yes, sorry. If end is less than start, then return. Your middle will look something like end minus start by 2 plus start. So node star node equal to new array middle. What will be node left and what will be node right?
Node left will be the recursive call of this.
This function. So let's say you call it something recurse, you pass in an array. What else do you want to pass?
Length, end and start you need to pass.
Recurse. So what will be end and start?
So start will remain start for the left part.
Okay, so I am passing over here, I am passing the integer array. I am passing start,
And end.
I am passing end.
So
Why an array?
Sorry. Yeah, sorry. Int start,
and end.
int end,
And then your recurse will be
Will
same
be
array.
array, of
Array.
course.
Start and mid minus 1.
Start and mid minus 1. Recurse.
And the end.
Array, mid plus 1. What will I return?
You will need to return node.
Node.
So you need a driver function for this?
Do you need to return null instead of just return
So then over here, what will you return?
null, right? Because
Convert array to tree.
will come here? What will be array dot
Length of what you are doing? 0,
what will be the end parameter? Initial length.
length minus 1.
Don't apply brute force, man.
I will have to devour one. If logically work.
Let's say you're given a binary search tree. What is the maximum value of this tree?
Five post.
Right. Okay. What is the fifth to the largest value?
11.
So I go a level up, and then that is second to the largest,
Five more.
third to the largest, third to the largest.
Oh, okay.
Okay. Third to the largest, fourth to the largest, fifth to the largest. If you had the array, you can always come back and say, okay, this is one. You don't have the array.
So you want the fifth largest or in specific largest value, right?
And kth largest. So your function will be like int find kth largest node star root and int k. I'll give you first two lines. Min int min, I don't remember what is called min int. Yeah. Think.
I think it's a in order reversal, right? So you keep on doing
Okay.
in order reversal and keep on maintaining the count.
Okay.
So it's like when you meet the kth,
Mhm.
then return that element.
No,
So you
it's
meet the
K from backside.
Kth
Both
from
from the back side you have.
kth largest, not the largest. So
K-
I'm not
K-
asking you the kth smallest, right? Kth smallest will be 1, 2, 3, 4, and 5. Or let's say if it were 5. 1, 2, 3, 4, and 5. I am asking you 1, 2, 3, 4, 5.
So it will be post order traversal, but
Post
instead
order
of the
traversal.
starting from left, we will do the right. So what I will do is like I will create a function find k, so int k, and then at the first state I will do if k is equal to 0.
You have to return. So just return root data instead of print.
Yeah.
Yeah, just
Return.
return.
Yeah.
So root dot data now we root data.
Can you walk me through
Yeah.
3?
So,
Let's say a small number 3.
so I'm first checking. Yeah.
If not root.
So if not root,
Mm-hmm.
then I'm taking this k is equal to 0, so it's not 0.
Okay.
I'm coming here root dot right. So with this recursion I will keep moving and I will reach till right.
Okay, we
Right.
reach till 15.
So till 15
Mm-hmm.
and
And then you return int min.
sorry.
You will return int min. The first line that I wrote.
Hmm.
So because then the root becomes equal.
Because your root
Yeah.
becomes null.
Right. So I will
Okay,
for
you
time
remove
being
that.
I'm removing
Okay.
it. For the time
Then
being.
you are going till 15. Then you'll
So
keep.
I am going till 15 and then I will swap this
Okay.
and over here.
But you will still go down and you will encounter a null reference exception.
So it will throw exception, that's what you said.
Oh, okay.
Yeah, because at 15
Yeah,
you will
because
still go to the node right. And then you try to go to the right of right. That is nonce right.
Yeah, I can check over here. Like
Mhm.
if root is not equal to null.
Null. If it is, what will you do? Otherwise,
Otherwise nothing, it will come out of this.
no,
And then
you have to return something. You
Yeah.
have to return a print.
Okay, let's check here as well. So return -1, which means I'm not finding any data, right?
What if you have a data organizer?
I think that will never happen that because we are saying like you return me the Oh, you don't have that many levels?
What if my root itself, what if all the nodes in this are negative? Right?
Why can't we just do pre-order traversal passing k starting from 0 till the k?
Come again.
So I think
Normally, in order traversal with k starting from 0. So let's say I'm trying to find the kth largest, which is the last one, right? I start with 8, k is equal to 0. So my first thing will be 4.
Why are you going to 4?
No, not
You
4.
don't know the length, you don't know the number of elements in the tree, right?
You don't know how many elements
Some
are
elements
there.
are there, so you cannot.
But I can do a
You
DFS,
can-
right? If I do a DFS,
Uh-huh.
I can, if say 1, 2, 3, 4, 5,
1, 2, 3, 4, 5, 6, okay, 1,
2,
2, 3, you are doing an in-order traversal, yeah, you're doing an in-order
another
traversal.
traversal, right?
4,
4,
5,
5,
6, blah, 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 you create the array that we just saw, okay.
Yeah.
You
So
have
if
14,
14 and 15, right?
Mhm.
So let's say you are trying to find the
third largest.
third largest.
So you go from the end to this, but that's not a good solution because let's say there are million entries and you want million minus 3 million minus 1. Yeah.
If you want 3, then you will have,
You have to traverse this entire thing. And
okay, so the, yeah,
Back to this system, I think instead of integer we can tell the node and then we can say null if it's not.
what if there is none? What if you had 8, 4 and 12? And I asked you for 5th.
Yeah, so in that case it's going to be null, right? So
Yeah,
so
and-
you return null.
And in this case also you are returning null.
In that case, like 5th we get.
After 15th you are going down, you reach null. If you encounter null, what do you return?
If we encounter null.
Okay, what if I were to, since we are out of time, stack everything? Six, 7, blah blah blah, 13, 14, 15, and then pop as many times as you want. You have the
That's
answer.
what I mean.
That's
So
what
if you
this
start
array is.
with k is
Yeah,
equal to
but
your max number.
can you improve that stack from stack? Because if you have million nodes, you have million.
stack it, right?
Instead, wouldn't it be better just to keep 3 or k elements at a time?
Yes, k elements stack.
So you are creating a window. Let's say you have this 1, 2, 3, 4, 5, 6, 7 and 8. Let's say this is your tree, correct?
Uh-huh.
You're doing a pre-order traversal on a binary search tree, so you will always have ascending order.
Ascending order.
So what if when you come here you say, do I have another one? Yes, I do. Remove this
Remove this
and put this in my queue. Correct?
Yeah.
If do I have one more? Yes. Then remove this. So your queue is gonna keep sliding till the time you reach null,
And-
DQ, and that one is your answer, right?
Yeah.
Solve. Oh, and think
A
of
little
that.
bit similar to the nth node from
Yes.
the linked list.
Yes. Actually, it was asked to me. I proposed a stack solution. He said improve it. Took me a while to get to it.
But can't we do this in recursion? Your question was valid that what will happen if root right is null? There would be.
You can do it with recursion. You'll have to just keep passing the queue.
No, without taking the help of Q. I don't want
Without
to
the
take-
help of queue,
without any other extra memory.
how will you keep a track of the values? So let's say at 5,
Yeah, so what, so logic is clear to me how I can do that.
Yes.
And the logic is that I go to the end to a right hand side
yeah.
and then start
No, you
moving
don't
back.
go to the right end at the right hand side. If you are going to the end and then going back,
Yeah.
You are not getting the fifth most. You're not. This is not the third
No, no,
largest.
actually he's going
No,
all
no,
the way
no.
left and then he's coming right as well. If you see
Like the the
Yeah.
code that I have written, it was not, it was going to the
Right
end
first and then
and
after
then left,
Okay.
then again up,
Uh-huh.
then again left, then
Okay.
again up and then left. That was the
Okay.
code. The way
Okay.
we write the recursion pre-order.
So
or
this is
post
your
order.
pre-order traversal.
Post order.
Post order.
Post order, but from right hand side.
how can
So your reverse post order.
Reverse post order. Yeah.
Okay. So you are doing reverse post order 15, 14, 13.
Yes.
Yeah, and keep on counting. I
No,
know that should work. Like I don't
Reverse post. Your post order is root,
So
right child, left child. This will be root, right child, left child. So there you will have 14, 15, and then 13. This is a reverse post order.
no, so reverse post
So
order.
I think what you are trying to say is you are
Right.
reverse in order.
Reverse pre-order. Huh?
What
Yeah,
about
reverse.
right parent left?
Reverse in order, yes.
Yeah. So right switch correct. Right parent left.
So this will be 15, 14, and 13. Okay. So you are doing a reverse in order,
Alright.
and you will keep
And then
doing this.
keep counting.
You'll have to find a way to keep track of.
I am passing k, right? And every time I am doing that, once I reach to the end, I am doing -1, -1. And the moment I reach to k equal to 0, which means
Yeah,
that
it
I
should
am
work, but you have to make sure that you decrement k only when you reach the largest element.
Yes,
You
that's what
are
I
doing it at the end.
That's what I was doing. At
You
the
are,
end.
if you are doing it at the end,
No, not at the end. I swapped it. So what I said that find largest dot right.
Okay.
If you write.
so
over there.
let's write a solution. What was it?
Okay, so if k equal to 0, return like root.
0 equal to k.
Return
Return
root.
root data.
Yeah.
Okay.
And then I'm saying like find kth largest.
Find kth largest whatever.
Largest
or
dot right. The root dot right.
root right,
Comma k.
comma k,
And then I'm saying k minus minus.
minus k.
Yeah. And then find k
Then find kth
root hyphen left
root left.
k.
Okay.
So what it is going to happen
So,
is first it will reach.
I don't know
right.
how you are going to stop at 15. I have no idea, but let's say you stopped at 15.
minus k
Yeah.
should be after the left,
Left.
isn't it?
No, it will be after the right. So it's correct because I want to reach to the rightmost node, and then I will do -1, and then I will move one node towards left.
If there is no rightmost,
So, sorry.
if there is no rightmost.
First of all, I don't know how you will
Don't
stop
even
at 15.
Yeah, that is the only problem. That is also, it's not affecting to me that how I will stop to that. I will have to put a condition over there that
Yeah, but
if
you cannot
root is
return.
equal to null, then
But what will you return?
I can take a biref or something. Biref.
Okay, let's do this. You make this void,
Yes,
okay?
and biref.
And then you then int result. Okay.
And I'm saying
And
root equal to null, then
Result equal to
root
data, correct?
yeah,
And
And-
then you return.
yeah. And first take I'm doing root equal to null, and
If not root, return. Okay. Okay, now let's walk through your code. Okay? Your root is 8.
yes,
0 equal to k? No, your k is, let's, root k. Your root is 8, your k is 3. Correct?
yeah.
You come here, you go to the right, 12.
So I will keep going till the end.
Yeah.
You're going till 15. Okay,
Yes.
Wait, let's do it correctly. 15. You come here, you say your 15th right is not present, so you come back, missing it.
Now I'm doing
Now you're going to the left,
so
which is
Null, so we will
14.
Null.
So we will
It's
come
left,
back.
null. Okay, that's fine. It will come back,
right.
and then where were we?
So then again it will do k minus minus.
Then it will do minus minus 1. And
And
now
then
it will go
left.
to the left 13.
13.
And then it has to come back. I am assuming it will go to 12 where it will be wrong. It has to give you 11, right? First, second, third. No. First, second, third. No, it's fine.
It's fine. So
Yeah.
it will go to 14
Mm-hmm.
and then again
At
it will
14
do k
it
minus.
will be, at 14 it is already 3.
Yeah. What do you mean by 3? Yeah, k is 3.
At
Right?
14 is it's 3, correct?
Correct.
15 it was 3, it became 2. But 15's left and right child are null. So it came out. At 14 it's still 3. No? You're going to the left. Okay.
15 is 3, 14 is should be.
No, we are passing that variable over and over, so it has reduced, right? Once you pass it over again,
It will k will
it will
keep on
reduce.
reducing, right? Because I'm assuming
Passing
that
the
k
same
is by ref.
Oh, k is up. No.
because
Yeah.
it is being passed, right? Again.
Yes, k is passed. Okay, but
So when I was at 15,
no, but when you were at 14, the k was 3, correct?
when
Then
I
you
was
pass-
You are traversing
fact-
14 for 2 times, if you see that.
Yeah.
So if you,
Let me try to run this one. So let's actually think from the stack perspective.
Yep, I am.
So for the first time, you're gonna come and you're gonna push 8,
8.
and
Okay.
value was 3.
Okay.
And then you're gonna go 12, value is 3.
Mm-hmm.
14,
value is 3.
And 15,
15 value
value
is
is 3.
3.
After that, you're gonna run minus kk, right? So you're gonna you're gonna
Null.
Null.
You'll have
it
Two
will
nulls.
become 2 on the same level, and then you're gonna pass left, so null. So you're gonna be null and
Two.
2, right?
okay.
Then you're gonna come back again.
no, why it will be null and 2? Because if root is null, it will return from there. It will not decrement the value of k.
Your 3 got your 2 got decremented then and there. At 15 itself, it got decremented.
So when you get a return, you go to next line, right?
Yeah, we go to next line. That's the difference. You're gonna come
Yeah.
back.
And
So
so
you're gonna
null
go
is
out, then come back over here, and then you're
So
gonna go
at
14.
15 I have decremented, and then I said that move root dot left. Root dot left is null.
null.
But what is
So
your root at that point in time?
Right.
Your root is 15, right?
No.
And this one
This
was
is 15, right?
15 over here.
15 is still 3.
So 15 actually, the
Put it on
friend,
the stack.
okay,
Because
15 is 3.
see, when you pass the null, right?
15 over 3 is over here.
But
Then come
at
over
this-
here.
No, at this point, you're passing 15, well, you're passing null with 3, right? So you get return here, right? You get return here,
So
right?
15.
Yeah, 15 have 2 nulls.
Yes.
So you pass this null, you have one more function call with the null value, you get return here, you subtract that. So you have null,
So it's like null.
null and
Null and
2.
null
This
and-
is your right null and 2.
You
Then
pass
you
one
come
more
back.
left
This is
for 15, right?
right, and then null
Left. For 2. This is your left.
left.
Again you have a decrement here, right?
Because between right and left, I think it's gonna decrement again. It's gonna become 1 over here,
Yep.
right? So then we
Then you go
remove
back.
this one, remove this one, and when it is 1, then you're gonna keep on,
You're gonna pass 1, right?
yeah, 1. So we have 15 and 1.
Yes. And then you are gonna call 14.
14.
At that point in time, you have 1.
Yes.
So you decrement it. It will become 0.
You will return 14.
Because your code will come out at 14.
14.
So it will be reduced and then it will go to left.
Left.
Like that time it will go here. And it's correct. But I'm not sure if it will work for other values. Try it.
It might require a little bit tweak, but I think
Yes.
this should
Some tweak will be required over there in the condition.
Okay, I want to give you quickly the hint to the perimeter.
Oh yeah, that was the starting.
Perimeter, not diameter. Diameter is, I'm still struggling with diameter. So when you are traversing, what is the speciality of these nodes?
Boundaries.
These are
And
leftmost node.
Leftmost, correct? So they have never gone right. These have never gone left. That's the hint.
What is that? Right.
Now these nodes have never, you have never gone right when you are traversing here. You have never gone left on any of these nodes.
Oh,
So print the
there
value.
will be so there will be one for left, one for right, and one for leaf, right?
Right and left is easy. Like how do you get like this one?
This is
That's
the
the
question.
because this has
Okay. For me, left and right was difficult because leaf is easy. Come on, leaf is straightforward.
It does not have any.
If it does not have left child and right child, it's a leaf.
yeah, but getting from the root, what is that leaf?
Just traverse.
So you are traversing how?
So
left first or left first?
So left and right is easy,
Left
right?
first
The
only.
way we call the
I think,
find function right now, root dot left,
Pre-order.
it will keep on going towards the left.
Yeah, but you are only to traverse once.
Yeah.
This one.
So just a second, if we don't have one, if I don't have one in here,
Okay.
8, 4,
If you don't have one,
and
sorry,
if I don't have 4 all, no.
you will
Pre-order.
not have to.
just print this pre-order, but only print the nodes which are rightmost or leftmost or leaves.
What is the condition for the leaf?
Leaf
Condition
you
is
don't have
no, you don't have
left,
no
right.
right.
So if there is no left and there is no right, you are
The perimeter of the tree. So you have to print for this tree. You have to print it like this: 8, 4, 2. It should be 1, right?
Yeah.
1, 3, 5, 7, 9, 11, 13,
Jay, is it right? Pre-order with
15,
leftmost.
14, 12.
Is it
Pre-order with
leftmost, rightmost, and the leafmost?
solve.
Three, yes. 5, yes.
So Saturday.
Saturday 10 o'clock.
What are we going to cover in that class?